In the late summer of 1958, the United States carried 3 nuclear bombs out over the South Atlantic, pointed them at the stars, and set them off in space, on purpose, in total secret. The plan was almost too strange to believe, to detonate atom bombs above the atmosphere and wrap the entire Earth in an artificial belt of radiation, a shield made of fallout, hanging in orbit over our heads. It sounds like something dreamed up for a film. It wasn't. There are firing logs, ship rosters, and declassified reports. Every word of this is on the record. It really happened. To understand how we got here, you have to meet one man, Nicholas Christofilos. He was not, at first, anyone the world would have trusted with a nuclear weapon. During the war, he repaired elevators in occupied Athens. But at night, in that occupied city, he taught himself physics from smuggled German and American textbooks. No university post, no laboratory, just a self-taught engineer working out the mathematics of particle accelerators alone. And he was right. His ideas were so far ahead that American scientists checked his work twice, convinced an amateur could not have found them. By the 1950s, the elevator man from Athens had a desk at the Lawrence Radiation Laboratory in California. This was the worst year of the Cold War. The Soviets had stunned America with Sputnik. The fear was simple and total, that an enemy missile could now be lofted over the pole, into space, and dropped on any city. And just months earlier, a scientist named James Van Allen had discovered something nobody expected, that the Earth was already wrapped in vast belts of charged particles, held in place by its own magnetic field, natural radiation belts, invisible, all around us. Christofilos looked at that discovery and asked a question that should have stayed a thought experiment. If the Earth can trap particles naturally, what happens if we inject our own? What if we made a belt of our own? His idea had a name, the Christofilos Effect. Detonate a nuclear weapon in space, and it would spray charged particles into the magnetic field. The field would catch them, sweep them around the planet, and lock them into an artificial belt. And that belt, the theory said, might be a weapon in itself, fierce enough to scramble the electronics of an incoming warhead, to blind satellites, to fry the guidance of anything that tried to pass through it. A wall of invisible radiation strung across the sky. On paper, it was elegant. The trouble was, nobody knew if it would actually work. The only way to find out was to do the unthinkable, and do it before anyone could object. There was a clock running, too. A ban on nuclear testing was about to begin, a moratorium that would shut the door on experiments like this for years. If Argus was going to happen, it had to happen now, and fast, and quiet. So they built a fleet, Task Force 88, around 9 ships, slipped south into the empty waters of the South Atlantic, far from any coastline, far from any eyes. The crews, for the most part, were not told what they were really there to do. The weapon itself was almost modest, a small warhead, around 1.5 kilotons, tiny by the standards of the age. The audacity wasn't the size of the bomb, it was where they intended to put it. They would mount it on a rocket fired from the deck of a ship and send it climbing, not toward a target, but straight up, out past the air itself, into the black, where no weapon had ever been deliberately detonated. And then they would wait. August 27, 1958. The first rocket leaves the rail and climbs into the dark. At roughly 160 kilometers above the ocean, far above the atmosphere, the warhead detonates. Argus 1. There was no mushroom cloud, no roar. In the vacuum of space, there is nothing to carry sound or shape, just a flash, swallowed by the dark, and then, on the instruments, something began to move. 3 days later, they did it again. Argus 2, higher still, near 290 kilometers. Then, on the 6th of September, Argus 3 detonated at an astonishing 750 kilometers up. 3 bombs, climbing further into space each time. And the sky answered. Above the detonations, auroras flickered into life where none belonged, sheets of pale color rippling across the night, conjured not by the sun, but by a bomb. Then the data came back, and Christofilos was right. The detonations had injected charged particles into the magnetic field, and the field had caught them, exactly as he predicted. A faint artificial radiation belt now wrapped the Earth. It was thin, and it was faint, but it was real. For a few weeks, humanity had genuinely strung a belt of its own radiation around the planet, and it did exactly what the theory feared. It degraded radar, it disrupted radio, it bent the signals passing through it. Van Allen's own instruments aboard the New Explorer satellites flew through the artificial belt and measured it from orbit. The man who had just discovered Earth's natural belts was now watching a brand new one, made by human hands, fade in the readings. By every scientific measure, Argus was a triumph. It would later be called the largest scientific experiment ever conducted to that point, and almost no one on Earth knew it had happened. The ships came home. The crews signed their oaths of silence. The reports were stamped and locked away. As far as the public was concerned, nothing at all had occurred over the South Atlantic that summer. But a secret that large does not hold forever. In March of 1959, the New York Times printed the story anyway, that the United States had detonated nuclear weapons in space months earlier and told no one. The paper called it the greatest scientific experiment ever conducted. The reaction among scientists was not all pride. Many had never been told that the very space their satellites flew through had been seeded with man-made radiation. And even then, the public learned only the outline. The headline named the deed, but the real details, the altitudes, the data, the full reach of the Christofilos Effect, stayed sealed. The story broke. The truth did not. The full file on Operation Argus would not be released until April of 1982, nearly a quarter of a century after 3 bombs were lit in the dark over the ocean. An entire generation grew up beneath a thing they were never told about. Christofilos himself never became famous. The elevator engineer who had reasoned his way from occupied Athens to the edge of space died in 1972, a decade before his greatest experiment was even fully admitted to the world. So here's where honesty matters most. It is tempting to call Argus a sinister secret weapon program. The plain truth is more deflating than that. As a shield, the whole idea was impractical. You cannot realistically nuke space to stop a missile. The artificial belt was faint, it faded in weeks, and it would have taken an absurd, endless barrage of detonations to hold any real wall in the sky. As a defense, it was a dead end, and the scientists soon knew it. So the prosaic verdict is fair. Argus was not a doomsday machine. It was a daring physics experiment that proved a clever theory and then quietly retired it. No death cloud, no hidden orbital weapon humming over your city tonight. That part deserves to be said plainly. And yet, 3 nuclear bombs were detonated in space, above an ocean, by a handful of ships, and the world was not told for months, and not told the full truth for 23 years. The experiment was harmless in the end. The secrecy was total. Those 2 facts sit uneasily together. Because the unease was never really about this one bomb or this one belt. It's the question Argus leaves hanging in the dark above us. If they could set off atom bombs in orbit and keep it quiet for a generation, what else was tested over our heads that we simply haven't been told about yet?